Okay, trig derivatives. On the left column, we have the 6 basic trig identities or trig functions: sine x, cosine x, tangent x, cotangent, cosecant, secant, and then their respective derivatives. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared x. The derivative of cotangent is negative cosecant squared x. The derivative of cosecant is negative cosecant cotangent. And the derivative of secant is secant tangent. So we've gone over those. And see the yellow highlighted? One way to remember, if you had to have this memorized if you didn't have a note sheet, is notice all of the original trig functions that begin with the letter C. Each of their derivatives is a negative. And not that that's any deep revelation, it just is a kind of a trick to help you remember which one's negative, which ones are positive. All right, so we'll just go through here. So I'm going to put this thing in parentheses. So now what we have, there's a chain rule involved. So the derivative of sine is cosine. But now, remember, sine is the f and the x cubed is the g. So now, remember the chain rule. It's the derivative of f with the g intact times the derivative of g. So the derivative of x cubed is 3x squared, and then you're going to bring that to the front. That's best practice. Mathematically, it means the same, but you would write it this way. All right, a cosecant one. Well, the derivative of cosecant is negative cosecant theta, cotangent theta. Then you have to multiply it by the derivative of the theta, then bring that in front. Because remember, 5 times 4 means the same thing as 4 times 5. All of this is multiplication. It just is better form for this to then say negative 2x times cosecant theta, which is x squared, times cotangent theta, which is the theta is x squared. The derivative of cosine is negative sine. So negative sine of theta, here's our theta, and the derivative of theta, using the power rule, 3x, 12. The 3 would come in front. 3 times 4 is 12. And then 3 subtract 1 is 2. And then we're going to bring that, rewrite that in front. So negative 12x squared times the sine of 4x cubed. The derivative of secant is secant theta tangent theta. And then the derivative of tangent is 2x. And so it goes like this. These are the trig derivatives. I'll go ahead and finish the next. I think we might have. Oh, and then there is a product rule that we'll get to next, but I'll finish these. Oops. The derivative of tangent is secant squared, and that's of theta. And the derivative of this theta, 2x to the fourth, would be 8x cubed so 8x cubed times secant squared theta. And then finally, this function starts with a c, so we know this will be a negative, so this is negative cosecant squared theta times the derivative of that theta, and then rewrite that simplified. All right, so that's finding the derivative of trig functions. Okay, and I'll do at least one of the product rules where one of the functions is a trig function. So we've got this. So that trig function is the f. The second function, the polynomial, is the g. So remember the product rule. It says f times g prime plus g times f prime. So you have to identify. So let's figure out the derivative of the f function. So the derivative sign is cosine. So it's cosine of theta times the derivative of theta. So the original f prime is derivative is 10x cosine of the theta 5x squared. Okay. Now we're going to look at the derivative of g. Well, that's just going to be 10x to the fourth. So then we can put it in this product rule. So dy dx is f times the derivative of g plus, let me do this, plus g times the derivative of f. And then if it can be simplified, do that. So for this one, 10x to the fourth comes out front times sine theta. Need to make my 5s look more like 5s than s's. And then let's see what we have over here. We can bring this out in front. Well, actually, the 10x can be simplified with both of those. So that gives us 20x to the sixth plus 50x, and all of that times, let me think about this. So I almost made a critical error because this whole thing right here is one unit. I mean, there's different functions there, but when we do the distributive, this becomes 20x to the fifth cosine theta plus 50x cosine theta. All right, so now we're going to look at all this. Well, all of those have a 10 in common. They also all have an x in common. And it looks like that's the only thing that all three share. So we're going to factor out a 10x, and then inside here, I could have just used parentheses. That would leave us x cubed sine theta plus 2x to the fourth cosine theta plus 5 cosine theta. So this lower one down here is how that would simplify. So you do have to be careful. I almost made that critical mistake there. All right, so those are working with trig derivatives.